Hey everyone, welcome to the exciting episode. It's another episode of the Life Chronicles, and as usual, I'm Simon William, and today I have a guest, a friend of mine who just stopped by for a conversation and a cup of coffee, trying to talk a little bit about some important information. But before beginning, I just wanted to get into your attention following things right now. Do you know that around 90% of our global trade is carried out by shipping emission, making it like a backbone of our international trade? On top of that, one thing that we have to understand is that the shipping industry actually contribute roughly around 500 billion US dollar annually globally. And if you put together, mostly Asia, particularly in China, is the largest hub for maritime activities, accounting for around 40% of a global container shipping. I do understand that because even by myself, I want to start a business a couple years, and I'm pretty sure I'll be add more in this list. But what we have to understand in here, it is actually a larger container shipping traveling for a distance. Like, for example, if you take a little bit of an estimation for Trans-Pacific route, it can emit around 16 to 18 grams of carbon dioxide per ton of a cargo per kilometer. Little bit on estimation, that will be like a pollution for much over like 50 million cars over the course of the entire year. I didn't understood this actually until today, that actually shipping is responsible for 2 to 3% of global carbon dioxide emission. That is a lot of emission globally. And we're going to have more discussion concerning this matter, especially shipping emission. And the person who stopped by for a conversation and a cup of coffee today is a friend of mine, Dr. Robert Gira. And even though he hates me to call him that, but I'm going to put a little bit formal in here. He's actually a research fellow in atmospheric composition modeling, geography, earth, and atmospheric science at the University of Melbourne. He is a researcher in atmospheric chemistry. He is most of his research interests actually include remote sensing of atmospheric gases like aerosols, using techniques such as DOAS. He'll tell us more about these techniques and stuff like that and later. And from a ground and satellite-based platform modeling atmospheric chemistry using tools like weather research and forecasting coupled with chemistry and GEOS Chem. He is currently working in a reef restoration and adaptation programs, cooling and shading teams, which aims to investigate whether maritime cloud can broadening and techniques could be employed to mitigate bleaching at the Great Barrier Reef. Rob, how are you? So let me go back to your own name that you would like to be called. Hi.
Hello. Yeah, it's great to be here, mate. Thanks for having me on. I'm good. How are you?
That's fantastic. I'm fine. The weather's getting better now.
Well, it was a lot better yesterday. It was 30 degrees.
Oh, yeah. Yesterday it was amazing, honestly speaking. And I did something horrible. I was trying to run, catching a bus. So it was...
That'll ruin even the best day.
Oh, amazing. So I want you to tell us something a little bit about your current project.
Yeah.
Because I think from that, and then we can go deeper a little bit about the shipping emission, especially in a Great Barrier Reef, what you're talking. Tell us a little bit about this current project you're doing.
Yeah, so shipping emissions are really one of the largest anthropogenic sources of aerosol to the ocean area, to the marine areas. Makes sense. I mean, most of the emissions that humans carry out are on land, but over the oceans, the main thing that we do to pollute the atmosphere is from ships. And so in an environment like the Great Barrier Reef, which is super, super sensitive to sea temperature and to aerosols, because aerosols control the amount of light that gets into the reef. So it's a marine environment that's highly sensitive to the aerosols, and the majority of those aerosols are coming from ships. So I've been involved in this Great Barrier Reef restoration and adaptation program for nearly 2 years by now, and been super lucky. I've got to go out on the reef and measure some of those aerosols and clouds. And also I'm involved in using some of the modelling techniques that you talked about to actually look at whether the best understanding that we have of the chemistry in the clouds is captured by those models, and then trying to use those models to predict what might happen in the future to aerosols and clouds and that impact on the reef.
Interesting. I do have a question, but before the question, actually, so that's a good intro about the project you're doing. But I have a question for someone who's not into scientific stuff. Let's say for a normal person. Let's say, for example, for a public who's not into scientific field and something like that. If someone asks you a question, okay, we say it's the largest emission, it's a shipping, which means most of the routes actually happening at the sea. Why do I have to care while I'm just, living in a dry land, in the mainland? Why do I have to care about shipping emissions?
Well, I think there's two really strong answers to that question. The first one is that even though ships spend a lot of time at sea, they all come into port at some point. And actually, shipping emissions constitute a really big percentage of air pollution in cities with major ports. So this is true in cities like Shanghai, for example, in China, and cities in Australia like Brisbane, Sydney and Melbourne that have ports. So that's the first reason. A lot of people live around the coast and they're actually exposed to more shipping emissions than they think. And the second reason is because ships impact global climate. So as you said, ships constitute 2 to 3% of global CO2 emissions. Did you know, here's another fun fact for you, if ships were a country, they would rank 10th in the world for CO2 emissions. So that puts that 2 to 3% in context.
So what you're trying to say actually is if we can try to put like an estimation, okay, let us assume shipping is the country.
Yeah.
And based on how much it produces in terms of carbon dioxide, it will be, oh wow.
It would be number 10 in the world. So it would be ahead of entire countries. Like 260 countries in the world have less CO2 emissions than the shipping industry. So we're talking about a big deal. And
okay, so something that I'm just a little bit curious, why most people don't know about this? Because once you're talking about pollution and emissions and everything, in general, people are more focusing, let's say, with industrial activities, others more like cars and something like that. Why most people don't know much about the contribution of shipping?
That's an excellent question, which I don't really have the answer to. I think, look, it needs to be said that it depends a little bit how you break the emissions down. So according to some emission budgets, the ships might be included in the emissions budget of some countries, okay? So that's part of it. Maybe in some cases it's included in other countries' emissions, in the way they report the emissions or the way they calculate them. But yeah, I think it's a really valid point. We often hear about people should take account of their carbon footprint when they go overseas on a holiday, right? So we're told that when we're flying in a plane, we need to be really conscious of our carbon footprint. But actually, we should be just as aware of the carbon footprint of the shipping. So for example, if you're going to buy a product on Amazon or some company, it doesn't matter which company, but if you're going to buy a product from another country and it's shipped to you in Australia or wherever you are, you really should be taking account of the carbon footprint of that product just as much as you should if you're going to take a plane flight across the other side of the world.
Okay, so here's another question. It's just something that I was just thinking. Most people don't know about the contribution of shipping actually the contribution of shipping in emission, especially in carbon dioxide and everything. And most of the focus actually is more in other aspects of pollution, But there is another thing that we can just put into consideration. My point that I'm making is because we always have like maybe 20 years, 30 years plans that we have to reach net zero, for example, which is the most common and something like that. And this is one of the questions that I always come across. People are always asking, is it possible to reach net zero?
Wow, we've gone very quickly from ships to a big climate question.
I'm just curious because it's a carbon dioxide and it contributes for around 2 to 3% of CO2 in the atmosphere. And one of the policies actually from IOM is they have a plan to reduce carbon emission actually from shipping industry, reduce the contribution of SO2 and something like that in atmosphere. And the question remains, well, they put into consideration like this is just like our plan to reach net zero. Is it possible? Let's put it into context for shipping. Let us stick from a shipping perspective.
Okay. Look, it's extremely complicated, and my sense of the answer at the level of current technology is no. It's probably not possible in the short term. And the fundamental reason for that is that the way we are considering reaching net zero for most transportation purposes is using electrification and battery technology. Now, that works okay if you're driving a car because you can top up your battery or maybe even replace the battery along the way. But we're talking in a car about journeys over tens to hundreds of kilometers and journey distances or journey times of hours. Okay, batteries can deal with hours. Batteries can't deal with weeks and months, and that's what we're talking about with shipping. How long does it take for a ship to travel from Europe to Australia or America to Australia?
Weeks, months.
Yeah, it's
sometimes.
about 3 weeks, I think.
Okay.
I mean, back in the day, it used to be months.
Oh.
But even if it's 3 to 4 weeks, that's an enormous amount of battery power that you need. And batteries at the moment are extremely heavy. So if you're a shipping company and you need to suddenly prioritize an enormous amount of mass and an enormous amount of storage space to batteries instead of burning diesel, the cost very quickly balloons out of control, and so there's a big reluctance to look towards battery technology for shipping. Same as aircraft. Because batteries are so heavy, it's a real limitation in electrification of aircraft as well. So those two that have really big distances and big times, we're really struggling to see how we're going to reach net zero at all. With our current technology of heavy batteries, I can't see it. But of course, technology is moving pretty quick, so I can't say maybe 20 years in the future we'll be able to have electrified ships run by renewable power. Then maybe it's possible.
I'll find someone we need to talk more about renewable power. Let me put into your attention the following things I've just put together here about policies, global policies concerning shipping emissions. The first one I think I have on the list here happened in 1997, which actually aimed to limit sulfur oxides and nitrogen oxides emission from shipping to reduce air pollution from ships. And their aim, actually, how to do that, the way they planned, was to control harmful emission from ships by enforcing limit on fuel sulfur content and encouraging technological improvements like better engines and using cleaner fuels. It is the same thing, actually, if you go down, because from 1997, 2005, they come up with a percentage now. Okay, so we want to reduce the sulfur content in ships was kept around 4.5% globally. If you go again, 2010, they reduced the percentage to around 1%. To 2015, they put it, okay, let's put to even more further. Let us tight our plans even more further to reduce it around 0.1%. 2018, they change now the focus. The focus will now set an ambition target to reduce total greenhouse gases emission from ships at least 50% by 2050. That was 2018. 2020, they come back again to the list in terms to reduce global sulfur. And their aim was targeting ships around 3.5 to 0.5. 2023, again, another thing continues, but this one is more into carbon dioxide. 2024, it's a continuation of the same thing. They do have a plan in here, for example, for 2030, which is to achieve 40% reduction in carbon emission from ships by 2030 compared to 2008 levels. 2050, the plan is just actually to reduce total emission from ships by at least 50% by 2050 compared to 2008. Now, I don't know why do they always have to compare with the year 2008? Because all of the policies in here, you can see, just compared to 2008. Was it the year actually we had the highest emission from ships or what? Now, here is a fascinating fact that I just want to put into your attention. So we've seen their plans to reduce shipping emissions. Here I put together a little bit of a timeline of carbon dioxide emission from ships per year. Actually from 1990s to 2020. So from 1990s, the CO2 emission from international shipping, it was estimated to be around 500 million tons per year. 2008 actually, they call it, this is the peak period, which emission were estimated to be around 1.12 billion tons of carbon dioxide, which contribute around 2.7% of our global CO2 emission. 2012, we have like a little bit of decrease in terms of emission, which was 960 million tons of carbon dioxide. 2015, 1 billion ton. 2018, 1.06 billion tons. 2020, 1 billion tons. 2022, 1.2 billion tons. 2023, they've just shifted now more into the plan to reduction of carbon emission, carbon intense by 2030 and 2050. Why do we always have to refer to the year 2008? That's the first question. And the second thing that I just a little bit curious in here, the plans to reduce emission based on the global policies are actually not matching with what we are emitting. Is it the issue of a population growth that increased the demand, that increase the transportation, while there is the continuation, the improvement of technology, actually, if you compare to the 90s? What do you think about it?
I don't know why we're comparing to 2008. I don't have an answer for that. I mean, there was a big global financial crash in 2008, right? Yeah. So it's quite possible that there was a bit of a slowdown in the CO2 emissions between 2008 and 2012 that you talked about there. That's probably got a little bit to do with that. Mm-hmm. And so it's quite possible that the peak of the global shipping occurred around that time, and then it's picked up a little bit again. So don't have a really good answer for that. But it's really worth noting that through that period, through the 1990s to the early 2000s, is a period dominated by the rise of China in the global economy. So China really coming to the fore as a major global player, and especially as a major player in global trade.
Which is actually 40% of ships actually are controlled by China.
Yeah, so that's probably a pretty good indicator of where a lot of this is coming from. Look, in terms of the lack of agreement between the policy and the results, it's not really that surprising, because we see something very similar for countries. Yeah. We see countries all over the world promising targets and not meeting them. This goes all the way back to the Kyoto Protocols and the Copenhagen Protocols and the Paris Climate Agreements, which have aimed to keep global warming to 1.5 degrees. Well, we're already there, basically. Yeah. And then sort of as a last-ditch resort to try and keep global warming to less than 2 degrees, and that looks pretty unlikely to happen as well. Yeah. So, look, I'm not really justifying it, but I guess just to say that the figures you present for global shipping not meeting its targets are exactly in line with every other sector and every other country. And there's something maybe we can think about it. We do have like guidelines, and then we have standards. Yeah.
For example, I'm more into air quality.
Yeah.
And here, like say for example, WHO, they usually provide guidelines, which technically in a long short information, these are just recommendations. Okay, we've done some analysis and do some research about the contribution of maybe air pollution in human healthy in 1, 2, 3, and 4. And based on what we have found out, we at least encourage countries to reduce pollution, the concentration, at least to a certain period.
Yeah.
Now we do understand that the concentration of pollution can be contributed by many factors. Could be meteorological factors and other small factors, but the most important was emission. Makes a point. Now, but UN always provide guidelines, but they do not set standards. Countries specific and states sometimes they can set their own standards. Like, okay, this is what you're saying, this is what you recommend, but based on the economic, situation in my country, this is what I set. And probably I might set the standard to reach certain kind of target, maybe in a certain years, but not current right now.
Yeah.
See, so is that have any relation with what we are seeing? These numbers are mismatched. Global plan actually is to cut off the CO2 emissions from shipping. But since shipping industry contribute like a lot of percentage to our global economy based on things that we use, manufacturing and everything, they have to be transported in one way or another. So we cannot skip that part. And to say that one country can get each and everything within the country, that would be lying. But countries set their own standards.
Yeah. I think that's absolutely true. But I think it's at this point we should draw a distinction between two very different outcomes here, from pollution in general and from shipping specifically. So there's two issues at play here. One is that when you burn a fossil fuel, you produce CO2. That's unavoidable. And burning fossil fuels is so fundamental to our economy that we're struggling to reduce it at all, across the board. Whether there's standards implied by the WHO or anybody else, we're not meeting them because we can't stop burning fossil fuels in our current economy right now.
Just to add something in there, I just want to ask something in there. You've pinpointed a very important thing. It is true that fossil fuel contribute a lot of global CO2, and we cannot stop. Is it because renewable energy currently is not sufficient enough to meet the global demands of energy?
Yes.
Or our technology is yet to reach that far? Because I do remember something. I don't know. I tend to be corrected on this matter. I remember when I was on my master's, actually, I was a professor teaching about green energy and something like that. He told us the efficiency of, let's say, for solar panel to provide let's say, good energy is around 30 to 40%. That goes along for maybe wind turbines and something like that. So I was just putting that into in your pathway as you were explaining something in there.
Yeah, no, you're right. The answer to that part of your question is both. I mean, we don't have enough renewable energy rolled out around the world, and too many of our processes are so energy intensive that our current renewable methods can't cover them. So, yeah, you're absolutely right. There's technological reasons related specifically to the renewable energy and related to the transmission of energy from renewable sources. That's maybe another discussion. But I think it's important for shipping to draw the distinction between the CO2, which I just mentioned, and that's a long-term climate effect. CO2 stays in the atmosphere for hundreds to thousands of years, versus the air pollution impact, which is quite different and is actually quite addressable. And so the figures that you read out for CO2 not matching the targets, it's actually, when we look at sulfur dioxide, we can see that the shipping industry is actually making inroads. They are actually reducing the amount of sulfur in the fuel, and if you reduce the sulfur in the fuel, you reduce the amount of sulfur dioxide that ends up in the atmosphere. And this is true on land as well. There are many places in the world on land where they are reducing air pollution emissions because they can clean up fuel. Like I said, they can't avoid burning the fossil fuel, but if you make the fuel more pure, then you remove some of the other parts of the fuel, like sulfur dioxides and nitrogen dioxides. Okay, so why is sulfur dioxide so important? Well, the reason is because sulfur dioxide goes on in the atmosphere to form sulfuric acid. And yes, that's kind of scary. So the major reason, Simon, that these countries started implementing sulfur regulations in shipping fuels was because the sulfur dioxide to sulfuric acid was so bad that it was causing acid rain in some of these port cities. That's the main reason that countries got together and the International Maritime Organization said, hey, we've got to do something about this sulfur problem. That's the main reason that it started. Since then, since you talked about in the mid-1990s and 2000s, they started reducing the sulfur, we now have a lot more knowledge that sulfur dioxide and sulfuric acid also goes on to create aerosols that block incoming radiation.
Can you explain more on that distinction between sulfur oxides and aerosols?
Yeah, exactly. So sulfur dioxide is a gas, same as carbon dioxide. But if you mix the sulfur dioxide in the atmosphere with water droplets in clouds, you form sulfuric acid. So without wanting to get into technical chemistry, sulfur dioxide plus water equals sulfuric acid. That's the chemical equation we're talking about. Now, sulfuric acid exists as a small droplet in the atmosphere. It's a physical droplet, like a water droplet. And that means once it goes from being a gas to being a physical droplet, it can block radiation. It can scatter radiation, just like a cloud. And not only that, but once it exists, it actually also influences the clouds. It changes the way the clouds form. So this is really interesting in a meteorological and a chemistry sense. It's just an interesting process for people like me to study, but it's really fundamental actually to the climate. If you have more of this stuff in the atmosphere, it blocks radiation. And if it blocks radiation, it actually cools the Earth down a little bit. This is so we got to a fundamental point here. Carbon dioxide warms the atmosphere. Sulfur dioxide has the net effect of cooling the atmosphere. There's competing interests here.
Adding to that one, when you're talking about the effect, I do remember when I was just writing my third book, actually, concerning the silent killer. There's something very interesting about, for example, Earth as the planet sometimes has its own way of cooling the temperature. Just for example, volcanic eruptions and something like that. But I think it was in 2019, 2021, the US Congress proposed the project. They wanted to call like a geoengineering something, whereby the concept was, okay, we have a problem here about the global warming. And one of the concepts that might help is actually the presence of enough sulfur dioxide in the atmosphere. Can't we find a way to pump enough amount of sulfur dioxide to block sun radiation? So as probably for a certain period of time, it might help to reduce the global warming. But here's the problem. There is something that probably we can clarify this one. There is something in here. There are kind of pollutants that are produced naturally, and there are kind of pollutants that are produced with our own engineering. For example, ozone, it exists both up in the atmosphere and here. But the one that we produce here is a little bit terrifying and more lethal. So maybe you can give us a little bit distinction between those two things in there. Sometimes maybe these, okay, if we do understand that even volcanic eruption, the SO2 can be more, intense and lethal, but that is more natural, and sometimes people just do like to create simple arguments.
Yeah, there's very few pollutants that humans emit that don't exist in some form naturally. It's all a question of the amount. So, yeah, we definitely know that volcanoes release enough sulfur dioxide and also physical ash particles to cool the Earth down. So, for example, if somebody wants to go and look up the global atmospheric temperature chart, for example, from the IPCC over the last 100 years, you see a bit of a slowdown in the global warming of the Earth around 1991. And this is well known to be because of the Mount Pinatubo eruption, volcanic eruption in 1991. And it put so much material, including sulfur dioxide and sulfuric acid, into the atmosphere that it cooled the planet down a little bit, counteracting the impact of global warming from humans emitting greenhouse gases. So yes, we know that this is an effect. We know that there are natural processes that have, over the course of millennia, acted to regulate the Earth's climate. We know that these processes physically work, but now it's worth saying that the greenhouse effect is natural too, right? The Earth regulates its temperature cycle with carbon dioxide through photosynthesis and animals and the whole natural carbon cycle of the ocean and the atmosphere and the land. So none of this stuff is entirely human, but we have had such an influence on it that we're going way beyond what the natural cycles are able to deal with. So if we've been able to change the carbon cycle with carbon dioxide so much that we're having all of these unintended consequences, situations that we don't really know what's going to happen. We know the climate's warming, but what's the impact of that going to be on the weather? We're still working that out. Okay, so once we see that this is so crazy, the influence we're happening, that we're causing, the suggestion that we would then go and try and replicate somehow a volcanic eruption to cool the Earth down, deliberately go and geoengineer a cooling solution when we still don't properly understand the impacts, all the impacts of the greenhouse effect that we've changed. How does that add up? You know, okay, the fundamental physical science looks like it works. We could cool the planet down. But honestly, we don't know enough about what that would do if we keep pumping sulfur dioxide up there to cool the planet down. We know a little bit from what we can see shipping emissions have done to bring it back to ships, but the amount that we would need to cool the Earth to counteract greenhouse gases is so big. We don't have a natural experiment for that. And mate, we've only got one planet. So what if we do this natural experiment, this unnatural experiment, to try and cool the Earth down? What if it goes wrong?
That's the question.
We've only got one planet.
Definitely. And the place, maybe by the time reach, Elon Musk will be already find out the way to, find another planet, probably Mars or some places like that. So let's go back to the shipping emissions in here. Based on our shipping emission inventories in here, let's focus in Melbourne. Can you tell us a little bit?
So we're quite lucky in a way, in the way that we want to track shipping emissions, because like airplanes, ships have to report where they are at any moment for safety reasons. Okay? So we know if a ship goes missing or, so ships don't run into each other. And we can use that information to track where these ships are at all times, so long as it's big enough. So long as the ship is big enough, I mean. So a guy in his fishing boat doesn't need one of these trackers, but a big ship does. So we know where they are at any one time, and we know what kind of ship they are, how big the engine is, what fuel they have, and so all of those pieces of information mean that we actually have a pretty good idea what the emission from ships are at any given place at any given time on the globe. So we know pretty well at any one time how many ships there are in the port of Melbourne or any other port. So if we want to do some atmospheric chemistry modelling, including the emissions from all of the industrial processes, I would say actually we're pretty confident in the impact of shipping. Compared to something like factories in different countries, which may or may not have to report their emissions accurately to the relevant local government, shipping has this international body, International Maritime Organization, that imposes the rules about having trackers and reporting the emission type. So, yeah, we've got a pretty good idea about what the emissions are at any place and time.
Based on the global recommendations right now, based on the global plans right now, and do we have like a global hotspot, a place where we have a highest shipping emissions globally? For example, in Africa, I can just give some idea. For example, South Africa. There is a region called Mpumalanga there, which is the global hub. They call it like a hotspot for NO2. China, for example, another country. When we're talking about shipping emission, do we have like a global place whereby right now this is the highest location, a single location that is the hotspot that produces so much emission?
There's actually a bigger place with shipping emissions in Africa.
Ooh.
It's called the Suez Canal.
Hey.
I mean, if you get all of these ships in one place,
Mm-hmm.
yeah, the shipping emissions are really bad there. Okay, that makes sense, right? It's a bottleneck.
Yeah.
So, yeah, any place where you've got a lot of ships congregating at any one time, it's going to be big.
Because it's a transport. It's just like a highway.
It's absolutely a highway. And so the big shipping lanes in the world have large amounts of emissions. You already identified 40% of the shipping in the world is from China. So it doesn't take a genius to guess where the largest shipping emissions are going to be. They're going to be in the major trade routes that China has with the rest of the world, and especially close to China because the ships are going to and from there for international trade. So the main answers that I would give you are, in general, the major shipping routes around China and India. So those ships are heading like between China and Taiwan, for example, between China and Japan, between China and India, round through Malaysia and Indonesia, Singapore, that kind of area. And then also anywhere in the world where you've got ships congregating in a shipping lane. So Suez Canal and Panama Canal. They would be the main answers.
Oh, yeah. I get it. I do remember about that one. If you are about to be given, let's say, an opportunity, like a card, I call it a card of change maker, what are some of the things that you will impose if you are giving you like a global control on a shipping emissions and something like this there? They contribute a large percentage, actually 2 to 3% is actually huge percentage. What kind of things that you can impose and what you think like, okay, if I have like a global change card, this is what I would do. And then you can just, and you can just classify it into different locations. For example, based on developing countries and developed countries, this is what they can do, this is what we can do, and this is, something like that.
Well, the first thing I would ask for if I have one of those cards is another card.
What is it?
Okay, anyway, that's a facetious answer. The most important thing as I see it is what I said before, that we are a very long way from renewable shipping. And in my mind, that means that we actually need to think about seriously reducing the amount of shipping more than trying to regulate the shipping that exists. Okay, so how do you do that? Well, we are constantly told throughout the world, and this is going to get political, we're constantly told throughout the world that globalization is a good thing. And a large part of globalization is international trade. And I do get that creates economies and creates jobs. But it does also lead to situations where countries are relying on international shipping instead of producing stuff at home. I'll give you an example. If I go into the supermarket here in Melbourne, I can find oranges on the shelf grown in Brazil. Now, Australia is a country with every possible climatic and soil type. We're huge. We've got a great, proud, strong tradition of agriculture in this country. we can grow enough oranges here to feed ourselves. So why on earth do we have oranges from South America that had to get here on a ship? Okay, so it's questions like this that I think are fundamental to understanding how we reduce shipping emissions. We have an incentive for global trade based on current economics that somehow says it is cheaper to bring oranges from Brazil to Australia than to put them on a truck from 200 kilometres away. I know where the oranges are grown in Victoria. It's only 200 kilometres north, in an area called Mildura. We're capable of growing enough. How is it cheaper to get them on a ship from Brazil? Okay, I'll tell you why it's cheaper. There is a price differential paid there, and the price is paid by the environment. That cost...
Hold on. You lost me there. Can you just explain a little bit? What do you mean? Because one thing that I have in my mind is just like, okay, once country decided, okay, we are shipping certain kind of products that are not available in our country, or they might be available for them, it might be like, okay, they're cheaper, more reliable, something like that. Yeah. Always come up with a political explanation of some things in there. When you're saying about the price, so it's a very valid point you've made about there are places at home we can produce enough here, and it's just like a couple 100 kilometers from here, and instead of using, let's say petrol or diesel car, we can use electric cars. Just go and grab couples, every product that we need at the farm, local farms in here, and then we can sell in our local markets. In the meantime, we have to ship from thousands kilometers using a thing that produced around just one route of a ship. It's enough for more than 50 million, equivalent to 50 million cars emissions of carbon dioxide per year per road, something like that. And you were saying that there is the price called per environment. Explain that a little bit to me, because I'm lost.
Well, I'm glad you asked me to explain this, and I'm glad you're lost in a way, because we're all lost. We all should be lost by this question of why it is cheaper to ship something from the other side of the world when it's capable of being grown here. That is a question that should make people scratch their heads. Okay? So, why is
I'm scratching mine right now.
Yeah, you're not. I can see it.
Oh, don't worry. I'm just scratching a little bit. Confused.
No, okay. How is it possibly cheaper? Well, the answer is because the pollution that is being generated is not being taken into account. Okay? So effectively the fuel must be so cheap per kilometre compared to, so for the shipping to be coming from Brazil, going back to my oranges example, for the shipping to be coming from Brazil versus the fuel in the truck to bring the oranges from Mildura, a few 100 kilometres away, the price differential on the fuel must be so big that the fuel cost in the ship must be almost nothing. Think about all of the labour that goes into growing those oranges in Brazil, all of the labour on the ship, all of the labour in the shipping company, all of the wages in the port authorities. Okay, if you add all of those up, and it's still cheaper to bring it from Brazil, the answer has to be that the fuel costs basically nothing. And what you do to the environment when you say that the fuel costs basically nothing is you say it doesn't matter that we've burnt this fuel and put the pollution into the environment. There is zero cost associated there.
There is the saying, says this: those who controls the printed pages controls the thinking of ages.
I like that.
So you've just give me another thing to think for the whole coming week, Probably. Here's another thing. It's a very interesting point because you're talking about the emissions and something like that. There's something I want to put into your account. Think about it for a minute. We are always focused on the final product. Forget about the progress, because emission is the chain of command. I like to call it a chain of command. It has different chains connected to it. For example, one of the things that was complained for a very long time is the highest concentration of nitrogen dioxide in the atmosphere. And the issue key associated with more industrialized emissions and vehicles emissions. Okay, based on a global thinking, let us change our focus. Let us shift now from using fossil fuel, from using fuel engines. Let us use electric cars. And they produce now electric cars. Now we can see and even right now, I'm so happy to see that the competition in the global market for electric vehicles is very huge right now. China, US, there's a huge competition in there. But there is something that I was just thinking that doesn't seem right to me. There is the famous picture posted in a social media. I remember I saw it on Instagram actually. There's a bunch of cars, can name the brand in here. And yes, they're charged electric, called electric car. But the electricity was coming from the generator outside using fossil fuel. It's a diesel generator, huge diesel generator to power these electric cars. And another thing, when I saw that picture, something comes into my mind, like, hold on now. We have a car in here, but this car, in order to have a car, there are certain materials we need. There is the progress. This is the final product. So we have from extraction of materials, pre-processing of the product, production, transportation, or we can say shipping the product from the industrial. And when you take a look closely, you can see clearly extraction of materials requires a huge amount of land. Sometimes they have to cut off millions of hectares, or then sometimes they have to dig tons of they have to dig a lot to get mines that are associated creating, let's say, lithium battery, for example, and then labors and something like that. And I remember when I was just doing the research actually in Africa, I was just reading some literature. One of the most common way they use to extract rock materials is by using blast technique. They have to blow up a piece of land, which emit tons of particles in the air. And what you were just saying actually is start making sense in here. There's a little bit more political situation going on than what we are actually doing. We are focusing on a final product. Meanwhile, the entire process, still we are polluting. And we say, okay, this product doesn't emit A, 2, 3, and 4. It cut emission to a certain point. But that is just the final product. What about the entire process in here? And they come across with that you say about environmental price. Doesn't make sense to me. Australia is the largest country plus the continent, regardless of the population the way it is right now, but there is a valuable piece of land, a huge available piece of land, can grow everything here. Why do we need something outside? Probably other things that we don't have. Yes, we might make an exception for that, but yeah, we can take a look of the process in here, and I think at the end of the day, still we can say there is the loophole. There is the problem along the way. Problem might be based on our policies, or we are touching economy issues in here, or political issues in here. And some of the other countries around the world, let us just face the fact, they are highly depending on production of fossil fuel, production of oil and something like that globally. And I think what you're saying makes some sense and a little bit more confusing to me concerning this matter, especially the emissions and something like that. Whoa.
Yeah, there's a lot to respond to there. First thing I want to say is, how does it work? How is it possible? Economically, it's possible because, of course, there are some things that some countries can't produce and don't have. So my example of the oranges doesn't apply everywhere.
Yeah, definitely.
So Australia doesn't have any oil. right? So we have to get it from Saudi Arabia or somewhere that does have it. So that's, and okay, then you implement policies to make that happen. If you live in the United Kingdom, they've got no coffee. They can't grow it. So they need to get it from South America or from Africa or wherever you can grow it. And in order to implement the policies that do that, you enter into trade agreements, and as part of the negotiation of the agreements, in order to make the whole thing work, people end up having to agree to trade things that they don't need to trade, like oranges between Brazil and Australia. So that's an economic point about how it can happen. Another thing that I want to raise based on your comments just there, you talked about how we focus on the final product and don't think about the process along the way. Or perhaps particularly we don't appropriately price the process along the way. So one other thing I want to add to that is that when you say the final product, what we think about in that case is the final product as it sits in your hand.
Yes.
Right? So I've got a cup here, and this cup has been made, and there's some process, and it's arrived in my hands with a nice cup of tea in it. But actually, it's not the whole process, and this is not the final product. The final product is when I don't want this anymore, and it becomes waste.
Waste, yeah.
Okay? So we never consider this as part of the process. We sometimes consider the process up to the point where a consumer purchases the product or uses the product. And if you're lucky and it's a cup, it might get a few years of use. But if you're unlucky, like a little bit of fossil fuel, you burn it and it's gone. Okay? But it's not gone, is it?
It's not. It's going somewhere.
The molecules still exist, and the molecules have really big impact, and that's the part that we really don't price. That's the part we really don't take account of. You're quite right. We don't take enough account of the process along the way.
The entire process, yeah.
And so that goes to the shipping emissions. That's part of the process. But actually, the products that we then get and consume, we have this consumer mentality that we have something, we consume it, and it's gone. But it's not gone.
It's still
and so then
somewhere.
we have a waste issue as well. And the waste issue is relevant, of course, for emissions of fossil fuels, but also for so many other things. You know, wearing clothes a few times and then chucking them in the bin. So they go to landfill. Using a washing machine and it has one little problem, so you throw it out instead of fixing it. All of these things contribute. And they all mean, actually, that we then go back around the cycle, okay? So you've decided that you're sick of that t-shirt. You chuck it in the bin. That means you've got to go and buy a new t-shirt. And that means that you're fueling the cycle, actually, that relies on bringing all of those products on ships from other parts of the world, playing into the fact that we require cheap clothing because we replace it so often. And so if we need cheap clothing, we've got to get it from somewhere with cheap labor laws. That's why we get it from China, because they don't pay their workers as much as we do in Australia. So if you actually hung onto your clothes a little bit longer and slowed down the cycle of requiring new and cheap clothes all the time, that would actually help reduce the shipping requirements.
Respond to this. What you're saying is just like a responder to this saying in here. They say the war is into demand and consumption and production. You demand, they produce more, you consume more. That's a key cycle in that one. And it's just like a living, breathing being that we have created. In order for that being to continue living, they have added more soil in there to make you want more.
Yeah, you've got to fuel the beast.
Definitely, to make you want more. Okay, that car you're driving is a little bit pretty old right now. We get a new model right now. This model is very good, can travel fast, luxury, can massage you, warming up during winter, or AC and everything. 1, 2, 3, and 4, a lot of things just to make you want more. And when you want more, they produce more. So we are continuing with the same cycle. And as I was saying in there, you've added something more important. We are more focusing on the final product. We are more focusing on the product we're having. But the final product should be what happened after you have get tired of your product. I can give an example. I went back home for vacation this last month. And, sometimes when you start put together things, learning some things, you start understanding that, okay, whoa, there's something missing in here. For example, we have a problem of mosquito in there. So in the evening, they would grab some mosquito spray and something like that, spray. And when it's done, throwing it away. But we have another problem. And the problem that we're having is the final product. So the only way people feel like, okay, this is the way that we can deal with it, let's burn it. And I ended up arguing a lot that, guys, do not do that. Why? We are putting a lot in atmosphere. And they say, yes, better in atmosphere. Here we put a lot of trash. And there is no place for us to put these trashes from here. Ended up to being like, for example, the city of Dar es Salaam. Now, this is old statistics, probably might be even more or less. Produced around 4,000 tons of trash per single day. And there is no place to dump them. And the only way they're doing is to burn. So they require more, which shipped a lot. And right now they're even thinking to expand the port, which will allow more ships comes in. Now there are other countries around the world. The focus is not even in, they haven't even invented shipping inventories, emission inventories. And that's add more problem. We don't know much of how much we are producing. Because what we're having about global estimation, we calculate based on what we have, based on the available data. I was arguing someday with a professor back in Taiwan, and I was just saying something like this. Hold on now. Yes, most African countries suffered with air pollution based on the WHO. Now hold on. Less than 10 countries out of 54 countries actually can give you data, valid data. More than 40 countries, we know nothing of what is going on. The estimation probably might be even more or less with what we're estimating. Yes, we are using satellite data, but there are still limitations in there. So what if what we are estimating about the global pollution right now, and there is the concept, the current situation with most countries, it's a war of who have a good economy nowadays. That require more production, that require more consumption, make people want more so as to produce more so as the country can have more money to feed the country and be more into global population. And what they are actually thinking is in the future years, based on the plan, based on the estimation from, I think it's UNEP, in the future year, around 20%, I think, or most large amount percentage of people will be living in Africa. Right now, there is an expansion of ports, there is an expansion of airports, there is an expansion of roads and everything. Probably might not have a place to go in the future. There will be pollution everywhere. Okay, so
arguably there's pollution everywhere already.
Oh, definitely.
But you're certainly right that if you're not monitoring, it's hard to quantify the problem. It's hard to. I guess it's true that you miss all of the problems you don't look for.
Yeah.
So that's kind of how it works, right? It's unfortunate that we don't have enough monitoring, and really that should be a priority, I think, for people around the world.
Rob, if you have a microphone right now that can penetrate, that can reach to the entire global population, all 8 billion some people around the world, and if you are given an opportunity to say something to everybody, what would be your final message?
My final message would be chill out and slow down a bit. I think as humans we are so hardwired to want the next thing, the new thing, the greatest thing, the latest thing. We're just so hardwired for progress. And we so often hear about economic growth. We so often hear about how it's important to grow and it's important to expand and it's important to progress. But history tells us that the most stable and long-lasting societies in history have been the ones that didn't expand too quickly, didn't grow too quickly, stayed within their realm and lived within their means. I come from a continent, Australia, where we have the oldest surviving population, the oldest surviving culture, the Australian Indigenous people, and that's of course a myriad of different cultures. It's not one homogenous group, but as a whole we know from the fossil and archaeological records that they're an incredibly long surviving group, and they were that way because they were able to live within their means. And from the perspective of how we live our life now, it looks like they lived a lot slower lifestyle, a lot less progressive lifestyle. And instead of all this consumerism and instead of all this growth and instead of all this latest and greatest, I think we should just chill out and slow down a little bit as a people, as a species actually, not forgetting that we're animals, we're a species of animal. We should think of ourselves in that way a bit more. Slow down, just take a chill pill and reassess exactly what our purpose is here and how we can be a better species for this planet. That's what I would say.
Slow down, chill out. Unfortunately, there is a lot to talk about when we're touching the issue of emissions around the world. It's not a thing that we can finish today, nor tomorrow, nor even the day after tomorrow, because we have to rewire our minds, think how we live, and plan for the better future. Because I can sit here and hear the cries comes from the year 2800 years, crying for the better change, complaining to us that we have destroyed the planet beyond what we can even imagine. One thing that I can say in general is that this is just the beginning of a new chapter and a new era. I want to wish you, each and every one of you, a very best of this week. And until next week, I'll have someone else and we'll have something to talk about. Until next time, Simon Williams signing out. Bye-bye.